All right, let's go ahead and get started. Hi, everyone. Thank you all so much for coming to our Demo Days presentation. My name is Thursland, and this summer I was a data fellow with the New York City Department of City Planning.
And my name is Dea Bardhoshi, and this summer I was also a fellow at the New York City Department of City Planning.
And today we're going to present the outcome of our summer project, which is called Mapping New York City Historical Liquidations. So when we walked into the city planning office during Coding It Forward orientation, our supervisor, Amanda, handed us a sheet of paper. On that sheet of paper was the outline of a request from the capital planning team at city planning. They'd asked the data engineering team to create a data set that would allow them and agency partners to better understand historical spending of infrastructure projects by including geospatial information where possible. I was personally pretty surprised that no such data set yet existed. New York City is at the forefront of open data initiatives, and in the age of big data, where seemingly everything is recorded, there's no single source of truth for city planners to reference when they need to see where and when capital money has been spent. So today we present to you the solution to this problem, which is the Historical Capital Spending Data Product. Historical Capital Spending is a database that aggregates historical liquidations of the New York City capital budget with geospatial information where possible. But you might be wondering, why exactly does that matter? So I'm from the South Shore of Long Island. I was in middle school when my community was devastated by Hurricane Sandy. Buildings, roads, and boardwalks were washed away by storm surge or buried in sand. And it's been 11 years, so New York is built back better than ever. But how long exactly did reconstruction take? That question is best answered at the community level because clearly some areas of New York experienced more severe, long-lasting damage from the storm than others. But which communities received the most capital funding for resiliency projects? And which areas saw their reconstruction projects completed the fastest? Which projects took the longest to complete? How much did they cost? And where were they? Without a spatialized historical spending data set, these questions are really hard to answer. But with the historical capital spending data products, we hope that city planners, agency partners, and eventually the public will be able to clearly answer questions like these. So it's important to get familiar with a couple of key terms that we're going to be using a lot in this presentation. The first is capital projects. A capital project is a project that costs $35,000 or more and has a lifespan of 5 or more years. So think fire trucks, bridges, or sewers. Next is historical liquidations, which refers to checks issued by New York City for capital projects over time. And finally, geospatial information refers to information that allows data to be mapped to a location. Think coordinates on a plan or the footprint of a building. So this data product was created by aggregating and joining data from two main sources, one for getting capital spending information and the other for getting geospatial information. The source of capital spending information is called Checkbook NYC, and this is an open source dataset interactive tool that tracks every single check issued by New York City 2010 to present. It includes nearly 2 million checks that represent over $130 billion in capital spending, and checks include information like a unique capital project ID, the managing agency, the check amount, and some descriptive text fields. But importantly, the rows contain no geospatial information. So the next step was to get the geospatial information. And for that, we used the Capital Projects database as our source, which is an internal data product built and maintained by the DCP data engineering team. CPDB contains data relating to all current and planned New York City capital projects, a subset of which have been mapped to geospatial information. Every project in the Capital Projects database is assigned a category, either fixed asset, ITT vehicle and equipment, lump sum, or no category. And in creating this data product, we used all the historical versions of this database dating back to 2017.
All right, so now we can delve into the 3 specific goals that we had for creating this data product. First and foremost, we wanted to categorize the records in Checkbook NYC in the same way that we do in CPDB. This is important because not all capital projects can be mapped to geospatial information. And it's specifically fixed assets as a category that are the most promising for adding this geospatial information. And so we want to prioritize categorizing projects as fixed assets and then performing the assignment of geospatial information. So secondly, we want to take the historical liquidation information from Checkbook NYC and use CPDB to add as much geospatial information as possible. And then finally, we want to take the initial exploratory results of our work and use them to construct a full-fledged reproducible data pipeline. So to talk a bit more about how we went about doing the data processing, as we mentioned, our raw data had almost 2 million rows, all at the level of checks. We were mostly interested in focusing in capital projects instead. And so we aggregated the data into around 16,600 rows, each corresponding to one capital project. From there, we also performed adding geospatial data from CPDB to these capital projects where it was possible. And then lastly, we also performed the categorization process using the same logic as in CPDB. So each project was assigned to either fixed asset, lump sum, IDT vehicles and equipment, or if none of those were possible, we would assign a value of none. And again, we want to maximize how many fixed assets we assigned. So here are some of the results of actually joining CPDB to the checkbook data. So as you can see, we were able to map around 3,900 projects out of our around 16,000 projects into geospatial data. And that corresponded to around $29 billion of spending. And what does this mean in terms of proportion of money or proportion of projects? So as you can see in the pie charts, the proportion of money that we were able to join to geospatial data accounted for around 21% of the total. And then the proportion of projects that were joined to geospatial data accounted for around 23% of the total number. And here's also some results on the categorization process. So as you can see, there's two main takeaways. First, we were successful in assigning around 92% of projects to one of the three categories. And then also importantly, around 61% of the projects that we were focusing on, we ended up being able to assign to fixed assets, which was one of our goals. And here is also some results of adding geospatial data and looking at that by category. So there is one of the main takeaways of this visualization is that around 85% of projects that we were able to map ended up being categorized as fixed assets. And this again made sense to us because fixed assets are physical infrastructure projects.
So as Dea just explains, the insights that we gained through our exploratory work made us realize that not only was it feasible to add geospatial information to capital spending data, but our results were actually really promising. Although we only mapped about 25% of the projects to geometries, like she mentioned, not all capital projects are mappable in the first place, and we saw a lot of success in mapping fixed assets specifically. So next we had to make our work reproducible, and we decided to take all of our ad hoc exploratory work and funnel it into the form of a data pipeline. But some of you might be wondering, what exactly is a data pipeline? A data pipeline is a series of data processing steps to extract source data, transform, and load it to a storage location, usually in the cloud. Data pipelines save time by automating the process of applying all the transformations one needs to turn source data into its desired output format, and make sure that both inputs and outputs are easily accessible. So the first step was the extraction step. We took our two input data sources, checkbook NYC for the historical liquidations data and the historical versions of the capital projects database for the geospatial data, and we uploaded these to DigitalOcean, which is our team's cloud storage platform, also known as our data lake. Next, we had to transform the input data. So we pulled the input data sources down from DigitalOcean and applied the following transformations. First, we did some standard data cleaning, making sure that column names were standardized, followed by merging the historical versions of the capital projects database so that all the geospatial information would be accessible in one place. Next, we collapsed the checkbook NYC data so that each row represented a unique capital project instead of an individual check. And after that, we took all the geospatial information from the capital projects database, we joined it onto the matching capital projects in checkbook NYC. Finally, we assigned every project a category using the same logic that we did in the capital projects database. And the final step was the loading step. So after applying the transformations, we had our output data set, the historical capital spending data set in which each row represents a unique capital project and capital projects have geospatial information where possible. We took this output and we uploaded it to the data lake on DigitalOcean. And today our data pipeline runs end to end using GitHub Actions. And if you're interested in seeing the source code yourselves, everything is publicly available on our team's GitHub repository. So now we have a functioning end-to-end data pipeline that maps historical capital spending to location data. But what exactly did we accomplish this summer and why does it matter? A data set like this presents a powerful opportunity to provide planners with the vital insights they need to do their job and to do it right. The example I gave at the beginning about analyzing resiliency spending in the wake of a natural disaster like Hurricane Sandy is just one of many potential impacts and use cases. And the thread that ties them all together is the desire for transparency and DCP's commitment to investing in equity. This data product will empower city planners to draw insights from the historical capital spending to make smarter, more fair decisions about where to invest in future infrastructure around New York City. And of course, the work that we did this summer is only the first step for this data pipeline.
And here's some possible directions our project can go on from here. And we've identified and already started working on 3 of them. So firstly, we believe we can improve source data by both using APIs to streamline the way we're ingesting the data, for instance, Checkbook NYC, or we can also layer in other databases as sources for locations, in addition to CPDB, which is what we're currently doing. Secondly, we think we can also enrich location information by specifically extracting locations from the descriptive text fields that our dataset already includes. And lastly, we would hope to make the data publicly accessible by both publishing it for the public and also creating an interactive tool that people could go in and explore. So what were some key learning takeaways for us this past summer? So first, we were able to gain a lot of experience with the technical tool the team uses, including data pipelining or visualizations. We were also able to present intermediate results of our work to different stakeholders, and communicating our findings to this audience was a great opportunity for honing our visualization and presenting skills. And secondly, we also got more experience working in city government. So in particular, we got to collaborate with people from diverse areas of expertise and just learn more about the interdisciplinary work that DCP does to bring all of these products together. And while we'll all specialize in different fields, we all share a common passion to make New York better.
So thank you all so much for coming to our presentation. Special thanks to our entire team, our supervisor, Amanda, the engineers on our team, Damon, Finn, and Alex, the whole staff at CIF, our CIF mentors, Elisa and Maria, the whole cohort, and all of you for listening. Thank you.
Thank you.
And if anyone has any questions for the time that we have remaining, feel free to drop them in the chat or raise your hand.
Yeah, for sure. So a few slides back, you were talking about the data cleaning and such. Recently for my job, we just started doing that, but different level. I started doing this yesterday, but it's like some interesting package called like Great Expectations in Python. I was wondering if that was something similar that y'all ended up using with your data, or if y'all did something else or something similar. It's just out of curiosity.
No, I actually haven't heard of that package before, but I'll definitely check it out. We pretty much stuck to pretty standard like Python data science libraries. We mostly use pandas and GeoPandas.
Gotcha. Cool. Yeah. All right. Thank you so much.
No problem. Thanks for the question.
Okay. I like this project. I was an urban planner. I know the maps, all the citizens, community like to see where that money spent. So I think one question would be, once you deliver the project, what kind of feedback you get from the planner? They're able to use it, what kind of insight they get through
Yeah, so the last meeting that we had with capital planning was actually about a month ago. So the first 2 sprints of our fellowship were spent doing exploratory work to decide, is this project feasible? Should we actually move forward with it and like create a whole data product? So they haven't actually seen like the full outputs yet. And I think we're probably going to work on enhancing it before we bring it back to them. But yeah.
That's so cool. And also you mentioned about using interactive tool. Think you use maybe like Power BI or Tableau, can provide the public access. So the public can play with this data.
Yeah, we definitely would love to do that like very soon.
We're actually in the middle of compiling a Streamlit page for this work as well. So that's going to be a first step towards the interactive tool.
All right, thank you all so much.